Okay, here we go. So I'm going to work it a particular way. Of course, there are other ways to work it. And as I was working through y'all's grades, I was kind of like, pretty nifty. Some of y'all did it a little bit differently than the way I did it on the key. So that's cool. So the way I'm going to do it here doesn't necessarily have to be the way you do it tomorrow on the retest, right? But you have that option. All right, so here we go. Step one, I'm going to draw a line down here. Whoop. And I'm going to start on the left. What most people did is put it in terms of sine and cosine. So 1 over sine times 1 over cosine. And then cotangent is an odd function, so the negative comes out front. And you got negative cotangent of x. So that would be a first step. Then I'll say that's 1 over sine x cosine of x. Put them under the same term. And then cotangent is cosine over sine. Some people are still calling cotangent sine over cosine. At this level, this late in the game, that's really unforgivable. All right, so now you have two terms on the left and one on the right, so you need a common denominator. So then we can multiply by cosine over cosine to get that common denominator. And now we can put it all over sine x cosine x. And your numerator is 1 minus cosine squared. And you're like, yay, 1 minus cosine squared is also known as sine squared. So that's sine squared over sine x cosine of x. And now, with the two sine factors in the top, one of them divides out, leaving 1 in the top, and no sine factors in the bottom, just the cosine. And sine over cosine is tangent. Boom. And that's it. That's the proof. That's the easiest, quickest way to do it. All right, so yeah, other people might have done it other ways, but that's the way that I would recommend. Cotangent is an odd function, bring it out front. All right, comments or questions on that one? Number 1. All right, let's move on to number 2. The first thing you want to do is focus on the two angles that are not x. This first one here, you could use the composite identity, sine of the first, cosine of the second, minus sine of the second, cosine of the first, and then you can evaluate sine of pi halves and cosine of pi halves. You'll get 1 and 0 respectively. But there's a quicker, faster, easier way to do it, right? That is a cofunction. What is the cofunction of sine? Cosine. So that's equal to cosine of x. That's a little bit quicker than using the composite identity. So if you didn't see that, you can use the composite identity. Minus sine squared of x, and then cosine is even, odd, or neither? Even, right? So that just goes away and becomes regular x. So that's the first step. All right? So if you can get down to the same angle, now it's pretty easy. There's two terms. There's a common factor of cosine. So when you factor it out, you're left with 1 minus sine squared. And of course, 1 minus sine squared is, or 1 minus sine squared, sorry, is cosine squared. And cosine times cosine squared is cosine cubed. Done. That's the right side. So I think if you recognize those identities, this was probably the easiest one on the front, or this required the fewest amount of steps. But yeah, there were other ways to do it. I'll get it, Raven. Thank you. There we go. All right, number 3. Number 3, a lot of people got right. That was cool. I like that. You have one term on the right. A lot of people got the common denominator by doing the crisscross applesauce. So start in the top left and multiply. You get cosecant x minus cotangent of x plus the other diagonal, cosecant x plus cotangent of x. So because that was a plus in between there, you didn't have to worry about distributing any kind of negative there. All over the denominator's product, which those are conjugates. So that becomes cosecant squared of x minus cotangent squared of x. And now good things will happen in the top, namely your cotangents will cancel, and then cosecant plus cosecant, that gives you 2 cosecant of x. And in the bottom, cosecant squared minus cotangent squared is actually equal to 1. But if you didn't recognize that, at least you know that you can write cotangent and cosecant squared in terms of each other. So that's what I'll do. Cosecant squared is 1 plus cotangent squared minus the cotangent squared that's already there. Now those cancel, leaving you 1. And if you did that, you would need to show the over 1. Remember, if there would be a reason for it, you would need to write it. And then anything divided by 1 is itself. And so that handles it pretty easily right there. Boom. All right. All right. So far, so good so far? Comments, questions, concerns, quips, good, clean jokes? All right, number 4. Number 4 was a good one to work on both sides, okay? A lot of people started on the right, which is good. But you're squaring a binomial, and you shouldn't be squaring a binomial incorrectly, again, at this level, this late in the game. A lot of people just wrote it as sine squared plus cosine squared. That's not true. Those are two of the terms, but remember, you get a middle term that is the multiply and double. So 2 sine x cosine x. Square, multiply, double, square. Or realize that you don't know how to square a binomial and write them side by side and FOIL it out, right? Now you're staring at Papa Pid. So that becomes 1 plus 2 sine x cosine x. On the right-hand side, then, you're done because you're not sure what to do to construct the left side. So you jump to the left side, and you realize it's not in terms of sine and cosine. So that would be a good first step. So it's 2 plus. Cosecant is 1 over sine. Secant is 1 over cosine. All over 1 over sine times 1 over cosine. Now those 1 over sine cosines do not divide out, but we do have a complex fraction. Hooray, hooray. And remember, when you get a complex fraction, the next step is to always eradicate it. So you need to multiply by a clever form of 1. That is the LCM. Remember, M stands for multiple. So it's the product, sine x cosine x, sine x cosine x. Now on the top, you have two terms, so you would have to distribute. So you're left with 2 sine x cosine x in the first term. And in the second term, sine x cosine x divided by sine x cosine x leaves you 1. They divide out. And in the denominator, a lot of people got this far, but then in the denominator, somehow it blew up. It's kind of the same thing. Sine x cosine x times 1 over sine, 1 over cosine is the same as dividing. You're left with 1. And now if you compare it to the right-hand side, all you got to do is commute the terms in the top. 1 plus 2 sine x cosine x, and anything divided by 1 is itself. So that pretty much finishes it off right there. Done. So that was one of those Diamond Rio songs, right? Meet in the middle. Ain't no road too long when you meet in the middle. That was a good one for meeting in the middle. Do a little bit on both sides. All right, comments, questions? There are other ways to do it. And again, some of y'all kind of did things, I could tell our brains work differently. Some of y'all did things very, very differently than the way I did. And that's what kind of makes it fun to grade. Like, oh, wow, cool. I've never been that route before. So you took me on a little adventure. So thank you. Number 5. Most people started on the right-hand side, which is what I would have done. Oh, look, I made a box. There we go. Noticing the left side is in terms of sine and cosine. If you can put the right side in terms of sine and cosine as well, that might work. So that's 1 over sine squared minus cosine x over sine of x times 1 over sine of x. Now, if you notice, the second term now is sine x, that's sine squared. So we actually already have a common denominator of sine squared. And in the top, you're left with 1 minus cosine of x. And so from here, there's a couple things you could do. You could either now jump to the left and multiply by the conjugate over the conjugate, or you could stay on the right-hand side and work with what you got, which is what a lot of people did. Sine squared is 1 minus cosine squared by Papa Pid. Now, what a lot of people did is they went straight from that line to this line here. And if you did that, you got an X because you didn't show that step. It's not real obvious or intuitive how to go from that line to that line unless I think you're doing it incorrectly. So what you need to show is this step right here. The numerator is still 1 minus cosine x, but the bottom is now a difference of squares, and it factors into 1 minus cosine times 1 plus cosine. That's a significant step to show. And now when you're dividing out binomials and they don't have parentheses, you want to put parentheses around them. So now those divide out, and then you are left with 1 over 1 plus cosine. So make sure you show all the steps. Remember, the process is your product. So when in doubt, don't leave it out. Show it. Show it, show it, show it. All right. And that concludes part 1. It was worth 8 checks. So what I did is I graded all 5 of them, and I took the 4 that best benefited you. And if you see an NG by 1, that means that was the one I did not grade. It means not graded, not graded. And if you had several that were just 1 check out of 2, I just chose 1 to not count. All right? Any comments or questions on part 1? All right, now we moved on to part 2, where you had to do all 3. These were solving equations from 0 to 2 pi. All right, number 6, since you have 2 terms with variables, remember the strategy was to get everything on one side and set it equal to 0. And you've got angles that are not the same, so you need to also work on getting them the same. Some people use the power reducing identity on cosine squared to make it a 2x, which is fine. I didn't do it that way, but that also works. But then you're solving multiple angles, which is what we're going to be doing on part 7. So the way I did it I'll show you the way I did it. I replaced cosine of 2x with the double angle identity for cosine, which remember there were 3 of them, right? There were 3 different ones for cosine of 2x. If you only remember cosine squared minus sine squared, that's fine. You're going to have to do a Pythagorean substitution on sine squared. But if you have them all 3 memorized, this would be a good opportunity just to write cosine of 2x as cosine squared of 1x minus 1, because it keeps it exclusively in terms of cosine. Saves a line of writing. So now what I'll do is I'll distribute the negative. So we get minus 2 cosine squared of x, and then plus 1 equals 1/2. And if you bring the 1/2 over to the left, that's fine, because you still have 2 terms of variables. But notice they're now like terms, aren't they? So if I can combine them, 1 minus 2 makes negative one of those. And so I don't want to bring everything to the left. I actually want to isolate the cosine squared. So if I bring the 1 to the right, I get minus 1 plus 1/2, which is negative 1/2. So had you brought the 1/2 across to the left already, that's fine. You would then bring it back to the right-hand side. So now we just need to solve for cosine. So I multiply both sides by negative 1, and I get that. And now I take the square root of both sides, and I have to remember to consider what? Plus or minus. When you take the eventh root of a number or anything, you got to consider plus or minus. So that's the square root of 1/2, which remember is the same, bless you, as 1 over the square root of 2, which of course is the same as plus or minus the square root of 2 over 2. So it is a unit circle ratio. And because it's plus or minus, we want all of the angles. If you missed the plus or minus, you lost the check because you only found probably 2 of the 4. So what's the reference angle where cosine is square root of 2 over 2? Pi fourths. So let's go ahead and list all of them as we rotate around. So the first one is pi fourths. Quadrant 2 gives you 3 pi fourths. Quadrant 3 gives you 5 pi fourths. Oops. And then quadrant 4 gives you 7 pi fourths. So there were the answers. So again, you got one check for a step, a legitimate step in the right direction, and then the second check was for the completion. Okay? Again, there were other ways to do that, but if you did do it another way correctly, you ended up with the same 4 answers. Yes, Will? Up here in the parentheses? The next line. I combine those. I have 1 cosine squared minus 2 cosine squared. Those are like terms. It's like having 1x minus 2x. It becomes negative x. They're both cosine squared terms, so they're like terms. So I can combine them to get minus 1 of them. Okay? Any other questions on that one? As long as they have the same stuff, they can be considered like terms. Okay, moving along to the next one. This one, we don't want to get everything on one side and set it equal to 0 because there's only a single term with a variable. So in this case, we isolate it. So sine of 3x would equal negative 1/2. Bring the 1 across, divide by 2. And now, since it's a 3x, we don't have to get it down to 1x. We just solve it as a multiple angle. So remember, we do it this way. Where is sine equal to negative 1/2? 7 pi 6 and 11 pi 6, right? Now, if that was just x, we'd be done. But because it's 3x, we're going to say plus 2 pi n plus 2 pi n. And we set them equal to the multiple angle. So there's 2 equations, and each equation is going to generate 3 solutions, right? Because it's 3x. So there should be a total of 6 solutions here. Now, some people got the wrong angles there, but they had the right idea. So I gave them 1 out of 2 checks. If we solve for x then by multiplying everything through by a third, we get x equals 7 pi 18ths plus 2 pi thirds n. That's the new period. And on the second equation, 11 pi 18ths plus 2 pi thirds n. And these are going to be then our equations that we can use to generate the solution. So I always start with the top one first, and it's going to generate 3 solutions. So the smallest one is the first one, 7 pi 18ths. And then we're just going to add 2 pi thirds. Well, instead of adding 2 pi thirds, what's a better version to use here? Since I'm adding it to something with 18ths, if I multiply by 6 over 6, I get 12 pi 18ths. So that's the version I'm going to use, right? It's equivalent. So I'm just adding 12. 12 is a magic number. So 7 plus 12 is 19 pi 18ths. And then one more, 19 plus 12 is 31 pi 18ths. So there are the 3 from the top equation. And now the bottom equation, very similarly, we start with 11 pi 18ths, and we just add 12 twice. So plus 12 is 23 pi 18ths, and plus another 12 is 35 pi 18ths. And so there are the 6 solutions. 6 solutions. All right, any comments or questions on that one? If you use the double, the power reducing over here, you did kind of the same thing with cosine of 2x. And some people did that. All right, now number 8. Number 8 was interesting. A lot of people really butchered this one up for some weird reason. Some people tried to factor it, which it doesn't factor very nicely. But there's only a single term with a variable in it. And remember, when that's the case, your goal is to get it by itself. So if you subtract 7, you get 3 cosecant square root of x equals 11 minus 7 is 4. And then if you divide through by 3, you get 4/3. That's where your first check came from isolating the trig function. Cosecant squared equals 4/3. A lot of people didn't even do that. But there's a single variable term, so you isolate it. Now you take the square root of both sides, and remember you're considering plus or minus. Well, that's the square root of 4/3, which is the square root of 4 over the square root of 3, which of course is 2 over the square root of 3. Now I wouldn't rationalize that. At this point, I'm like, you know what? Where does cosecant equal 2 over the square root of 3? If you think, well, in terms of cosecant, that's great. I still don't, because I haven't ever had to do it. Because I know if I have a cosecant ratio, I also have the what ratio automatically? The sine ratio. So what I'm going to do now is flip both sides. The reciprocal of cosecant is sine. And what's the reciprocal of 2 over the square root of 3? Square root of 3 over 2. It's solving the same equation, right? So might as well help yourself. If you have a cotangent, turn it into tangent. If you have a secant, turn it into cosine. So now it's pretty easy. Where is sine equal to square root of 3 halves? That's going to be what reference angle? Pi thirds, right? Pi thirds. So it's all of them. Pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Yeah, so if you got this far with plus or minus, but you did all your pi 6 angles, you lost that last check. All right, so that concludes part 2. There were 6 checks on that one. 2 per question. Comments, questions, quips, concerns on part 2. All right. Now moving on to the last part. You had to do 3 out of 4. Tomorrow, remember, you're going to have to do all 4 out of 4. And on part 1, you're going to have to do all 5 out of 5. No curve. This one here was similar, if not exactly, to one that was in the homework. So I'm going to start on the left side because it's in terms of tangent. I'm going to put everything in terms of sine and cosine. So that's sine of x, cosine of x, minus sine e over cos e. All over sine x, cosine x, plus sine y, cosine y. And hooray, 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 what have we just created? A complex fraction. And anytime you have a complex fraction, the next step is to eradicate it by multiplying by the LCM over the LCM, which is cosine x times cosine y. So cosine x times cosine y, cosine x times cosine y. I'm going to squeeze that in right there. Some people squeeze it in on the left, wherever you can squeeze it in. Remember also, if you multiply by a clever form of 1, you do need the division bar there. Some people have levitating expressions, which is kind of creepy. Chris Angel type math. Ooh. All right. So now we have 2 terms in both top and bottom we have to distribute. So if you distribute to the first one, your cosine x is divide out, and you're left with sine of x, cosine y. That's your first term in the numerator. Minus distributing, you get sine of y times cosine of x. Your cosine of y is divide out. In the bottom distributing, your cosine of x is divide out, so you're left with sine x, cosine y. And then minus your cosines divide out, and you're left with sine of y, cosine of x. So at this point, you could jump over to the right-hand side and use the composite identity to expand it and be done, or realize, hey, it's the same thing. This is sine, cosine, so it's sine of xy, and remember we keep the sign for sine, and then at the bottom it's sine of xy again, but this time it's plus. And if you compare that to the right-hand side, it's exactly the same. So there's that one there. A lot of people got that one. All right, now number 10. Those people who attempted the tangent of pi 30 seconds bonus flew through this one. with no problem. If you weren't even interested in the bonus, you didn't get a chance to really practice your tangent of x halves, and you probably struggled on this one. All right, so I'm going to start on the left. It's the square root of 1 minus cosine of x all over 1 plus cosine of x. Some people called it sine of x halves over cosine of x halves, and then use the sine and cosine identity separately, and then your 1/2 divided out, which is where this comes from. So that was fine. That's just an extra step. But this is the tangent identity as it was given to you. All right, so now if you give them each their own radical, top and bottom separately, you can start looking at the right-hand side. And you're like, okay, my denominator's looking good now, but it has a radical there. Man, it'd be great if I can get rid of that radical. So let's go ahead and do that by rationalizing. We'll multiply by a clever form of 1. That is the denominator over itself. The denominator over itself. And now, when you multiply in the bottom, radical times radical, when it's the exact same radicand, it's just the radicand. Now, on the top, they're different radicands, so we can't just let the radical go away, but we can multiply them under the same radical. And those are conjugates, right? 1 plus cosine, 1 minus cosine. That becomes 1 minus cosine squared. And then 1 minus cosine squared, hey, that's sine squared. So we got the square root of sine squared over 1 plus cosine. And now you compare it to the right, and you're like, man, I'm almost there. The square root of sine squared is sine of x all over 1 plus cosine of x. And there it is. That was the proof. Pretty nifty. So far, only one of them we've jumped to the other side. All right, the next one, this was the one where I was trying to throw everybody a bone, kind of at the end of the test, like, come on, people, do this. So the top is like, 1, that's Papa Pid. So at this point, that earned a check. I was giving you a check for a step in the right direction by calling that 1. Now the bottom, you need to get the angles to be single x's, so you could have used the double angle identities for sine and cosine. That works. But hopefully you also recognize that as sine cosine minus cosine sine, these two can flip around quite easily. That's the identity for sine, composite identity for sine. Your angles are 2x and x, and we keep the sign. So that's really the same as sine of 2x minus x. So that was the simplest way to do it. And then, of course, from there, what is 2x minus x? X. And then 1 over sine of x is cosecant of x. And that's the answer. If you use the double angle identities, you can still get there. It's just going to be a little bit more scenic. And, of course, you would have to have parentheses up here when you replace cosine of 2x because it's 2 terms, and you have to distribute a negative sine of x. So that was the easier way to do it. Several people did it that way. That was awesome. Rain did not do it that way, but he got it right. He actually used the double angle identities. So see, there's more than one way to skin a cat. Okay, but we don't know that here because when you do that in your biology lab, the cats that we order always come pre-skinned, right? Has anyone here dissected a cat in their biology lab? I guess you get to do that as seniors. The cats that you dissect come pre-skinned. And you can just imagine at this cat skinning factory, there are like several people that are doing it different ways. Okay, but we don't get to see that because we order our cats pre-skinned. All right. The next one. We got that dense nucleus on the left-hand side, sine to the 4th of x. That's the easier side to start on. We need to double the angle twice, from x to 2x and 2x to 4x. Let's reduce the power. So if you can call that sine squared squared, that's great. I'm going to go ahead and call it sine squared times sine squared, which makes a little bit more sense to most people. And I'm just using the power reducing identity twice. I'm just using the power reducing identity twice. So it becomes 1/2 1 minus cosine of 2x times 1/2 times 1 minus cosine of 2x. There it is, twice, right? So now the 1/2 times 1/2, that's a 4th. And now I have 1 minus cosine of 2x times 1 minus cosine of 2x. So I can either FOIL that out or square multiply double square. I'll do it that way. So you get 1 when you double, and multiply and double, you get minus 2 cosine of 2x. And when you square it, you get plus cosine squared of 2x. We worked a couple like this in the notes. There was even a quiz question like this, so this one should have been pretty straightforward. Now we got to do it one more time. I still got a cosine squared there, so I'll leave the 1/4 factored out. I get 1 minus cosine of 2x, and then here I get times a 1/2, 1 plus cosine of twice 2x, which is 4x, close, close. If you miss a parenthesis, that could be detrimental as well. Okay, so now what I think most people did here is factored or distributed the 1/2, which is fine. You could also factor out a 1/2 at this point. But if you distribute, you get plus 1/2 and then plus 1/2 cosine of 4x. And now if you notice, you can combine those, oops, not that one. You can combine these two. Those are both constants. So 1 plus 1/2 is 1 1/2 or 3/2. So we get 3/2 minus 2 cosine of 2x plus 1/2 cosine of 4x. And if you peek at the right side, it's looking pretty good, except the right side has a 1/8 out front. So that's your signal that, hey, we need to factor out a 1/2. So if you factor out the 1/2, a 4th times a 1/2 is an 1/8. And factoring out a 1/2, remember, is the same as dividing out a 1/2. And dividing by 1/2 is the same as multiplying by 2. So if we multiply everything on the inside by 2, I get 3 minus 4 cosine of 2x plus 1 cosine of 4x. And if you compare that to the right-hand side, yeah, it looks beautimous. Absolutely beautimous. As they say in Cajun country, I guarantee. All right, any comments or questions on that one? This, of course, was part 3, and it was worth 6 checks. So I graded all of them, and I took the 3 that were the most correct to give you the maximum number of points, and then the one I didn't grade, I put NG by. Okay? So hopefully you choose to retest tomorrow. Even if you made a 99, you can get 100. Right? If you made 98, you can get 100. Everybody's eligible to retest. But remember, you got to work all of them now, but now you know exactly how to do them all, and there's no curve. So really, everyone should walk in tomorrow or Wednesday and make 100, right? And everybody should be getting 50% of their points back, right? And that's a win-win because y'all are getting points back because y'all are playing the numbers game because you're students, right? And I'm winning because y'all are learning trig identities and trig proofs, right? That's win-win. Yes, Santi. In calculus? All the time. We use trig and trig identities all the time in calculus. After calculus, not so much at the HEB, to be truthful, right? You don't use them checking out, not I'm using when I'm like selecting pinto beans off the shelf. Do I go with Van de Kamps or do I go with Bushes? I don't know. Let's ask Papa Pid. Okay, that doesn't happen. But yeah, the main purpose of mathematical education is to get you to what? Think. To think and think critically. Absolutely. And there's no better thinking critically exercise than trig proofs. It's kind of like recreational. It's good for your mind. It's even good for your soul, right? All right, so any questions about tomorrow? Let me stop the recording and then we can